Hello, beautiful people. Today we're talking about 7.4 hypothesis testing for proportions. Our SWABAT is going to be to use the z-test to test a population proportion P. So the z-test for a population proportion is a statistical test for a population proportion, obviously. Proportion, though, they're not going to use that word. They're going to use percent, like the average percent of people that smoke cigarettes, or the average percent of people is greater than or equal to blah, blah, blah. So it'll be a percentage, and we'll use the decimal point form of it. This can be used when the binomial distribution is given such that n times p is greater than or equal to 5, and n times q is also greater than or equal to 5. So we'll be given the p. In order to find the q, just as a reminder, q is equal to 1 minus p. This is a huge font here. I'll fix it in a minute. So the test statistics, the sample proportion is going to be p hat. So when they say the sample, so you collected this many people, your sample size was like 40 or 50 or whatever, and then you will find a certain proportion based upon that. That's this. This is like your sample standard deviation and your sample mean. Instead, this is your sample proportion, and we call it p hat. To do this by hand is the same way that we've done it by hand before, but today we're going to be using technology, so be prepared with those graphing calculators if you would, please. Now, moving on just a little bit. Thought I can move that with my finger. Psych. Using a z-test for proportion p. So first thing that we're going to do is verify that we can do it by just multiplying n times p, and n times q has to be greater than or equal to 5 for both of those. And we're verifying using the sample distribution p hat. So this is really like a p hat here and a q hat there. We're going to state the claim mathematically. So this is the same thing we've done before, where we're talking about the null hypothesis and the alternative hypothesis. We're going to specify what the alpha is, how confident do we need to be here, or how, well, level of significance. Keeping it moving. We're going to determine any critical values is what we're going to determine. And number 5, we're going to determine the rejection regions, which you've done before. Remember, the shaded area is what we reject. We're always going to reject the shade. Number 6, find the standardized statistics using this formula, except today we're going to use our graphing calculators instead. And then we're going to make a decision, and then we're going to interpret it. One thing that's really, really helpful, because you're going to have some of the more common alphas, which would be 0.1, so it's 10%, 0.05 or 0.01. These are going to be the common ones that we use. And so if it's a left tail test, we'll have this and then right tail in 2. We've seen this before in a previous lesson, but we're still using the same one. So let's say if I was going to just kind of talk about this one just a little bit. Change this. As in this one. If I'm talking about a 0.05 alpha, then for the left side of it, this part right here, the alpha is 0.05, and then the z-score would be negative 1.645. If it's a right-tailed one, then the z-score would be positive 1.645. This is a negative. And then this would be my rejection area. So any z-score that would be anything that's like to the right of 1.45, that's going to be my rejection area. Any z-score that's to the left of 1.645, so if I had negative 1.7, that's rejection. Anything out here is rejection of the null hypothesis. And then for two-tailed tests, for this one right here, if this is your bell curve, then it's positive and negative, what? 1.96. So 1.96 on the positive side, negative 1.96 on this side. And the reason why the z-scores are a little bit different, because remember, if it's a two-tailed test, it's not just directly like this is alpha 0.05. But because there's two of them, you split the alphas in half. So half of 0.05, if you were to do this on your calculator, and divide it by 2, you would get 0.025 would be this area. Kind of embarrassed I did that on my calculator. And this area would be 0.025. So that's how that works. And these are the common z-scores that we'll be using. So kind of want to make sure that you have access to that for an assessment, for example. Here's our first example that we're going to work through. A medical researcher claims that 5% of children under the age of 18 have asthma. In a random sample of 250 children, 9.6% say that they have asthma. At an alpha equals 0.05, so at a level of significance of 0.05 or 5%, is there enough evidence to reject the researcher's claim? So first thing I want to do is kind of just, I like to underline important things. So this is my claim here, and he's claiming that 5% of children have it. So this is going to be P is actually equal to 0.05. Let's up with this pen. Sorry. And this under 18 years old doesn't really have anything to do in terms of my sample stats, so I don't really care too much about it. But I do know that my sample size is 250, so my N is 250. And then, so in that sample, I have found that 9.6%. So my P hat is equal to 0.096. Okay. And I also know that my alpha, because that's this point right here, is 0.05. So that's my level of significance for that problem. A lot of information there. So first thing that we want to do here for your steps is to identify the claim. So, well, here's the claim, is that P is equal to 0.05. So my null hypothesis is that P is equal to 0.05. My alternative hypothesis is that P is not equal to 0.05. So as I'm writing these things in my head, I'm thinking, okay, this is going to be a two-tail test because it's equal to for this one. As a sentence, what we are saying is that the claim is that 5% of children under the age of 18 years old have asthma. 5% of children under the age of 18 have asthma. That's our claim. Part B is to find the critical values. So critical values for that one would be, what is your Z? So scrolling back up, or you're just flipping your page, wow, what a coincidence, we kind of already have it down. For 0.05, and it's two-tailed because it's equal to, I know that my z-score should look something like this. So my rejection area is here and here. So what is it that they're asking us for part A? So if you're looking at this, then for part B, let's see if we can see both of them. There we go. Critical values, we're looking mostly at z being positive and negative 1.96. And so if you're looking at this area here, then what we're saying is if this is reject and this is reject, that in order for me to be able to approve this, then it has to be somewhere in the middle. So what they really care about is, for part C, what are my rejection areas? My rejection areas are any z that is, so remember the area to the right of it, if it's greater than 1.96, I'm going to reject it. If z is less than negative 1.96, I'm going to reject it. Okay, I made a little bit of an edit here. Sorry about that. B and C kind of go together. I was trying to look for your homework to see how it asked you. So this is when you're identifying the rejection region. The next part that they're going to ask you to do, though, is to identify some standardized statistics. That's the Z. So if you have your graphing calculator, go ahead, please, and let's follow these steps together. So first thing it tells you to do is to press Stat. So once you've turned it on, press Stat, and then you're going to hit the arrow to the right twice, and that's going to take you to Tests. And then we have done Z-test, we've done T-test. Now we're going to hit number 5, which is a proportion test for just one. So go ahead and hit number 5, and then we have some information to enter. So the first thing that we want to do, or the first thing that it asks you for, is what is the claim for P? What's the claim for P? And going back to the original part, our claim was that P is equal to 0.05. 0.05 for that one. What else? The X part of this is the number of students or the number of people that were actually found to have asthma. That's what the X represents, like the actual number of people. And so to find that, in your sample, you found that 9.6% of the people had it. So as a decimal, that's 0.096. So 0.96 times how many people actually had asthma in your sample? Well, 250. So 0.096 times 250 is equal to 24. So in my sample of 250 people, 9.6% of them had asthma. Well, 9.6% of 250 is 24. So for the X value on your calculators, you're going to put 24. Then when you scroll down for the N, that's the number of people that were in your actual sample. So that's going to be 250. 250, because that's how many people were in there. So then you're going to go ahead and scroll down, and it's going to ask you proportion. It says PROP, and then there's a colon. So which one do you need? Well, because the claim originally, the null hypothesis was P equals 0.05, and your calculator only speaks in the alternative. So you're going to highlight where it says P not equal to, or actually it probably says not equal to P. Not equal to P. All right. Once you have that, beautiful people, go ahead and press enter, or calculate rather, and see what you get. Hopefully, if you entered in your numbers correctly, you'll get the same thing as me, which is a screen that tells you that Z, that's the part that you actually care about because you're looking for the test statistic, Z. Z is equal to about 337. So part D, at least on your actual homework assignment, is going to ask you, are you going to reject this or are you going to fail to reject this? Well, that's the question. So if you're looking back at your region that's acceptable, we know that my rejection is going to be anything that's greater than 1.96 or less than negative 1.96. This number is a lot greater than 1.96, so I'm going to have to reject the claim. Reject. And then part E is when I'm going to have you write your sentence. So written out in everyone's favorite font, there is enough evidence at the 5% level of confidence to reject the claim. That's it for that. Everyone have a great day.